Hi, Year 12, and welcome back. Now, this is the second video for the first exercise in Chapter 5, Applications of Trigonometry. Right, just to keep the videos short and manageable, right, I've separated this into two different sort of parts of it. Now, this time here, we're still dealing with right-angled trigonometry, but we've got two triangles. For the three examples that are provided here, I think they're all improved with a better diagram, right? And diagrams are such an important part of these questions involving pretty wordy problems. So I think this diagram here is going to be much more helpful if I draw it like this. Right, so there's Sally. It's going to be Tim. It helps if you draw things vaguely to scale. Oops. So, stop that. Sally and Tim, vaguely to scale. Okay, so I think if I draw it like this, right, that's 40 meters. 40, not 46, 40 meters. 60 meters. Right. 35 degrees. Okay, so this is our situation here, I think. This is going to be the height of the building. This here is going to be the angle that I want to find. Okay, just check those things. Pause if you need to. But part A, the height of the building, is going to be this one here. The angle of elevation from Tim is going to be this angle here. Remember, angle of elevation is from the horizontal, looking upwards. So, for H, I have my angle here, the opposite and the adjacent. So it's going to be a tan question. Tan 35 equals H over 40. Therefore, H is 40 tan 35. Calculator tells us that that is, oops, thank you calculator, 40 times the tan of 35 equals about 28 meters. Right, that looks pretty good to our diagram. It should be a bit less than our 40. Now for part B, now that I know what this is, right, again, I've got the opposite and the adjacent. So again, it's a tan question, but this time, tan theta equals 28 over 60. And theta is the inverse tan of 28 over 60. And back to the calculator. So there's my second function tan, right? Inverse tan of my previous answer divided by 60. Reducing the rounding error as best you can here is good. I think though you'll find that people are generous with marking these things when it's a two-part and one of the answers carries over. So 25. Let's do this. 25 degrees, 1 minute. Prefer 0, 1. Rightio, like that. A better diagram, I think, makes things a bit clearer there. Again, this diagram here, I think the back-to-back triangles work nicer for us. Okay, so I'm going to have this sort of thing going on. Same situation, really. Angles are clearer. Right, so this one is 70 degrees. So I'm going to have both G and D being the same point. Right, so that could be G or D. I don't mind. I know that this one is 50. This one is 60. Rightio. And what I need to find is, I want to find the angle string from Diego's kite makes with the ground. Okay, so I want this angle here. It is very much like the last one. If we come back here, right, we can see that we start off with, with not quite exactly the same information, but close enough. So I have this side here. I've got the hypotenuse of this. If I can find this side here, x, right? If I find this side here, it's common to both triangles, right? And that's going to be via opposite hypotenuse is the sine, right? So I'm going to use sine to find this side here, and then sine again to find that angle, right? So sine of 70 equals the opposite x over 50. So x is 50 sine 70. Right, my calculator will tell me 50 sine 70 equals about 47 meters. 46.985. Now, I also know that theta is 46.985. Oops, sorry, sine of theta is 46.985 over 60. So theta is the inverse sine of that. Right, calculator back. Come on, calculator. Where are you? Why has that gone over there? Maybe it is in the road. Okay, inverse sine. Second function, sine of 46.985 over 60. Right, see that's in the brackets. Don't do the sine of that angle, the inverse sine of that, and divide your answer by 60. Right, make sure that all of this is in brackets. Either use your fraction, use divided by, it's fine. Make sure it's in the brackets. Make sure you get the order right. Okay, and I get 51 degrees, 33. Remember, we round up from 30. So 51 degrees, 33 minutes to the nearest minute. Okay, and the third example here, well, it says example 6, but third for this video here, we don't have any diagram. We've got to draw one. I've got Greg standing 70 metres from the base of the building. Julie, 40 metres from the base of the same building. So, here's the ground. We've got 70 on one side, 40 on the other. And, I don't know the height of the building. We're like this. Greg, 70 metres. Julie, 40 metres. Okay, there's at the top of the building. Now, from Greg to the top of the building, 35 degrees. From Julie to the top of the building, right, that's what we don't know. I want the height of the building, and I want the angle of elevation here, right? Come back here, very, very similar to this one here, except for the 40 and 60. Right, so you see these right angle problems with two triangles, usually it's a matter of this back-to-back stuff here. So just very quickly here, for A, the height of the building, right, my height, sorry, sine 35, no, not sine, tan, and very frequently these application ones are tan, tan 35 equals h on 70, h is 70, tan 35 equals, we've got two of these now, 70, tan 35 equals, and it's 49 meters tall, right? And for part B, tan theta, I should put my theta in there, right? Remember, your diagram is part of your working, is 49 over 40, so theta is the inverse tan of that, of 49 over 40, equals, Second function 10. Remember, finding an angle, use second function, right? The inverse function there. 49 over 40 is 50 degrees, 46 minutes. To the nearest minute. Rightio. That's the more advanced ones here. You can see this video's gone on for a little bit here to go through those examples. I hope they are instructive. See you in class.